x squared y double prime plus x y prime plus x squared y is equal to 0. Okay, and as usual, you just you can start off by letting y equal this, and then working going through. And let's not do that, and I'm just going to give you what you get out. Okay, so in the end you get a naught of r minus 1 plus r x to the r plus a to 1 r plus 1 r plus r plus 1. Let's see that I didn't clean up my notes. Plus summation n plus r squared a sub n plus a sub n minus 2 x to the n plus r equals 0. Okay, so that's what happens when you substitute into the equation. Okay, you get these things that are forced.
Two questions. First is, does that summation start at n equals 2?
Yes. Sorry.
But more importantly, so when we're to get there plugging in, do we start with the equation that you started, or would we do the whole, like what we do, finding p and q and then plugging it into that equation where we multiply through by x squared?
It shouldn't matter. It shouldn't matter, but I think probably at this point, plugging into this one is the best thing.
All right, so you don't have to find like divide by p, q over p, and then plug in from that.
Well, you see, this one is already sort of in that form already, right? It's already in the form where you divide it out and you multiply by x squared. So I think you probably want to plug into that. I don't know. It shouldn't make any difference, but. Okay, so what you see here is this thing is the thing on the 0th term is the indicial. This is the indicial equation, right? And you see you get r squared minus r plus r, so you get r squared has to be equal to 0, right? So here we see that so 1 that r squared. So what do we see? Setting everything equal to 0, we see that r squared has to be 0, right? So we get r is 0 and 0, right? We get a double root, right? What else do we see? This is r squared, r plus 1. This is just r plus 1 times r plus 1. Right? So we get a1 r plus 1 squared has to be equal to 0, right? And the third thing we get is that n plus r squared a sub n minus 2 has to be equal to 0.
How did we start off with case r equals 0?
Oh, we're just doing the things. We're just doing that things. Okay. So that all these guys are Bessel equations, right? Mm-hmm. We can do, for any v, this is a v.
Oh, okay, that makes sense.
So we're just taking one of the Bessel equations. Okay.
How do you simplify to get a1 times r plus 1 squared equals 0?
We're using the law of distribution.
Okay.
So here you've got r plus 1 times r. You've got r plus 1 times 1. Right? So you pull out the r plus 1, and you get r plus 1. Right? You pull out an r plus 1 this way, you get an r. Pull out an r this way, you get a 1. So, yes. If you hear something growling, it's my stomach. Hungry. I did get a grill today. I was once in a like this gigantic group of cellists who were doing a recording, and the engineer called in and said there was a strange gurgling noise from near the first from the first cellists, and then like the number one cellist was like, it was me. It was my stomach. I could catch everything on the mics. Okay, so we're in the case of double groups, right? And we see that if we are using r equals 0, then our a1 is going to be 0, right? A1 is A1 being 0 in the case r equals 0. And we have our recurrence relation, right? Our recurrence relation is a sub n must equal -1 over n plus r squared, a sub n minus 2, right? And so everybody depends on the guys who were 2 steps before, right? Each one depends on the guys 2 steps before. And so if we're looking at the simple case, I'm sorry, there's only one case, right? So, right, so if we take r equals 0, right, then we know that a1 is got to be 0. We know that an is -1 over n squared, a sub n minus 2. In particular, a sub n is 0 for n odd. Right? And then for the evens, for n even, right, a sub 2m, if you work it out, you see what happens. Right? A sub 2m, if we step down, it's going to be 1 over 2m quantity squared, a of 2 times m minus 1. Right? Just as we did before. Right? And if we step down another, right, you see what's going to happen. Right? A sub 2m is going to be -1 to the m, 2 to the m, m factorial squared times a naught. Right? I think. Yes, that's right. But no, it's not right. 2 to the 2m. Because we get 2 squared every time.
Is that n factorial squared?
Yes, n factorial squared, because we've got this squared here,
Yeah.
right? So every time we step down, we get a 2 and we get an m, right? So we get 2m, right? If we step down one more, we're going to get 2m squared -1 over 2m minus 1 quantity squared is of 2m minus 2, right? So we get 2 squared and 2 squared. Every time we get a 2 squared, so we get 2 to the 2m, right? And here we've got m squared and m minus 1 squared. So we're going to end up with a factorial, m factorial squared. Okay. So in the end, we get our first solution, the easy one. Y sub 1 is going to be a naught times 1 plus summation -1 to the m x to the 2m over 2 to the 2m m factorial squared from n equals 1 to 3.
Where do we get that x to the 2m from?
Because the a to the 2m, a sub 2m are the coefficients for the x to the 2m. Right? Right? Each of these guys is a coefficient for x to some power. Right? And we saw that all the odd powers have zeros as coefficients. And so we're only left with the guys with even powers.
So in the actual series itself, I always get like a little bit confused because the way that they have the answers in the book, it starts like the series, the odd terms are 0, but therefore the series, like the terms, I don't know how to say this. The 0th term, the 1st term, the 2nd term are like, they change into those terms even though, I'll ask you later, I don't know how to word it. I'm just wondering because like even though the odd terms are 0, when you make this series, like it just like the odd terms turn into.
No, there are no odd terms. So
Okay.
you've got m from 1 to infinity,
Yeah.
right? And you've got x to the 2m,
Mhm.
right? So it's, it's like the cosine,
Mhm.
right? The cosine has only even terms in its power series expansion. This guy also has only even terms in its power series expansion. There are no odd terms. They're gone. So does that answer your question? Or?
Yeah, it's fine. I don't know.
And we know that because they were the 0.
Yeah.
Whatever odd term depends on A1.
Yeah. They're not there. They're gone. There are no odd terms, right? Because we know that right, the coefficient for x, that was 0. Right? The coefficient for x cubed, the coefficient for x cubed was -1/9. I'm sorry, yeah, -1/9 times the coefficient for x1, but the coefficient for x1 was 0. Right? So this coefficient is also 0. All the odd terms, guys, have 0 coefficients. Okay.
Is m in this case, oh, m is equal to 1, okay, yeah. I didn't figure it out.
And goes from 1 to infinity.
Yeah.
Yeah, and goes from 1. Okay. So we're not gonna get to the more interesting part yet. We'll do it next time. But let me just say that this guy is a well-known function. It's called the Bessel function of the first kind. First kind of order 0. And it has a symbol for it. It's always called J sub 0. I think I first saw these guys in an analysis course. It's related to number theory. They curve this out.
So that's like the equation for what and how. Because you're saying this is that's like the equation of what would like this is how they put it.
It's the equation for the shape of the drum head. Yeah, it's like the basis of those